So in this exam style question, we're told that a copper connecting wire is 0.8 meters long and has a cross-sectional area of 1.1 times 10 to the minus 7 meters squared. So here they'd like us to calculate the resistance of the wire, given that the resistivity of copper is 1.7 times 10 to the minus 7 ohm meters. So here we just have to remember what our formula for resistance is. Remember that resistance is proportional to length. So we're going to have to times it by L, and inversely proportional to area. So the bigger area you have, the less resistance you have. So the biggest cross-section area. So we have to divide it by A. Then remember that the constant of proportionality there, the constant we put in front of that is just the resistivity, and we call that rho. So that's our equation for resistance. And we should start by writing that down because that's showing that we're on the right track, and should get you a mark just for writing down the correct equation. We have to remember that it's L over A, not A over L. It can be a little bit confusing when we look at resistivity. And remember that resistivity is kind of we have to flip the A and the L upside down. So do make sure you remember the right way. For resistance, it's L over A. For resistivity, it's A over L, as we saw in our previous exam style question. So now we just have to work out what this is. We're told everything we need. We're told the resistivity, we're told the cross-sectional area, and we're told the length. Remember, here we're told the cross-sectional area. We don't need to go about working out, what it is in terms of pies and diameters, etc. We don't need to do that because we're just told straight what A is. So what we need to do here is substitute in our numbers. So here we have written out all of our numbers that we were given, and all we have to do here is basically put this into a calculator. The first thing we should do though is just make life easier for ourselves by cancelling off some things. We see that this 10 to the minus 7 is going to cancel with this 10 to the minus 7 here, so our answer is going to be left in terms of something on the order of 1, and then all we need to do is cancel off our units properly. We see that this meter and this meter will cancel off with this meter squared, so we'll have our answer left in ohms, which is what we want. So we can rewrite this out and then just put it in a calculator. So if we do this, we write down 1.7 times 0.8 divided by 1.1 ohms, and we just put this into a calculator. We find the answer is 1.236 ... Now what do we have to leave our answer to? Well, we're only told 2 significant figures in our question, so we should really just lead us to 2 significant figures in our answer. So it's basically 1.2. So it's going to be 1.2 ohms to 2 significant figures. We should remember to write the correct unit down. Obviously, resistance, the unit for that is ohms, as we've just worked out here. So the next thing we're told is that a 12-volt, 30-watt lamp is connected to a power supply of negligible internal resistance. Now, that's often mentioned in questions. We will learn about this later. It will come up in a later video. We don't need to worry about it now. So basically, whenever you see negligible internal resistance, just remember that we don't have to think about the thing that we will learn about later. So for now, you just don't need to worry about that, but it will make sense later. Using 2 of the connecting wires. So we're basically we've got 2 of these wires, each of resistance 1.2 ohms, and...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.